Ma'am, you can start. The rest will join by. Ma'am, we cannot hear you if you're speaking.
Sorry, oh my God. Okay, ठीक है, I'll just start again. So I was just saying, in aging, today we're going to complete the last topic of this chapter, the aging. Okay, it's a normal topic, not so important, but it's good to know what are the genetic changes happening in our body that leads to mortality. What are the external factors that affects, and how do at chromosomal level, what are the changes are happening in our body. Okay. So now how you can say that the aging has started. What is aging is like the normal cell is been reconditioned, or there is a change in chromosome or DNA starts. How and when the change will start? So do the definition, they say after a reproductive life, when what is the main factor or individual role, evolutionary role has been accomplished. So once the reproductive age has been completed, or once it's done, slowly the deconditioning or slowly the changes will happen in our cellular level, at our chromosomal level, in our DNA and everything. And that's how we lead to the mortality. Okay. So old age is a concept of longevity in the human being. The consequences of aging appears after reproductive life, when evolutionary role of the individual has been accomplished. Okay. However, aging is distinct from mortality and disease. Almost aged individuals are more vulnerable to disease. Why someone would say that old age people are more vulnerable to disease? Because the reaction to any outwards pathogen or anything is very slow, or it's very changed in old age people. So let's just assume that reproductive age is still 35. I'm just giving a random number, 30 to 40 years. Okay. So after that, what will happen? The cell will react into different manners. Degenerative changes are happening. Even the uh, this OA is happening. Arthritis is happening. At the cellular level, things are changing. So they are more prone, and they cannot fight back in the way the young people can do. Okay. So they say the mechanism of even the hemostasis means to stop the blood flowing. That's what hemostasis does. Okay, if we are having a cut or something, how early 5 years old or 15 years young person will heal, the same healing process won't be seen in at the age of 60 or 65. You won't be expecting that. Okay. So what happened with aging, the mechanism of hemostasis is slow. Hence, the response to various stresses takes longer to revert back to the normal structure and function. Okay. The average age that primitive man was barely 20 to 25. So now they are just giving a comparison. In 1947, the age expectancy was around 26, but now in India it is around 64. So you can say a person who is healthy enough, or who is eating everything in outside, or a balanced middle class person who is sometimes eating outside, or have a bad habit like drinking alcoholism or something, balanced way, not doing regularly. Okay, not doing overdoing anything. Let's just say they are doing but once a month, twice a month. So there is a balance thing. So the average a person who can live is 65. Till 65 years, the life has been expected. So the maximum they have seen is 110 years. Okay. Now, when we compare, now we are just talking about human beings. Well, let's just compare between men and women. So they say that women are more prone to live longer because they don't, they have less, they're less prone to such disease, which includes heart, coronary disease, or any uh, other things. Because even the life, the way they live the life in compared to male, there is some alcoholism, there's some smoking involved in them. So that is even a major factor that affects it. Okay, I'll just read it out so we do not miss any point. Higher life expectancy in the woman is not due to difference in the response to somatic cell of the two sex, but higher mortality rate in men is attributed to the volatile violent causes. The greater susceptibility to the cardiovascular disease, cancer, respiratory disease, for which why they are susceptible to that, because of this habits, maybe cigarette smoking, alcohol consumption. There are the two main factors they are affecting, okay, playing a major role. There is no on the gene level or on the genetic level there is a difference between women and men that will say okay, women are less prone to that. In general, the life expectancy of the individual depend upon this following factors. So these are the four normal factors being discussed on which the life expectancy of the human or individual is depending to some extent. So first would be intrinsic at the genetic level, how the gene is. Some people or generation wise, some are very obese. Okay, their mother, their grandmother or everyone are obese. So even their genes are more prone to have that muscular build. On the other hand, some people are lean because they have that kind of food or they have that kind of situation in their home. So it has been generation wise, not had been changed. So that can be one thing. Even there are something when there is a twins, okay, between two people. So this apolipoprotein E4. This is a protein which is causing or keeping us to more prone to have a heart attack in future. So when we ask, whenever someone is having high BP or something, we take a family history, because there is a high chance that this kind of gene or this kind of cell has been there and got activated after years. Maybe some people are not drinking that much or do not smoke as well. They have a healthy diet. But what happened if their father is having BP, they had a high BP or diabetic or had a heart attack or stroke, and that has been running in their family, that even his grandfather had a BP issue. So what will happen? This gene, apolipoprotein E4-ln, is associated with with the heart disease and Alzheimer's. Okay, so we can expect it, he might be having it as well. But in twins, what happens? This gene is not present. This protein is not present. So they are more prone to live longer. Okay, so at genetic level, you need to understand that sometimes what happens, the type of cell, because we all know that how children are then, like we have the genetic makeup, the chromosomal level, we have the makeup of a cell, okay, for the individual or for the infant. So that is going to play a very big role for this heart disease, any Alzheimer disease, Parkinson disease, those things. Other would be the environment. It depends on the diet as well. Any toxicity, if someone is staying in that area where there's so much of factories are there, so they might be inhaling some kind of toxic in day-to-day life, in compared to the people who are staying in a good environment or in a mountain hilly places or a good place where they can breathe good. Okay, so comparison would be the environmental factor also plays a very important role. So other would be a lifestyle of the individual, such as the disease, means how what kind of life he is living. It cannot be like just alcoholism or just cigarette, but even sometimes if someone is poor, they do not have a good quality life. They cannot, spend that much money to have a good food. That would be a reason as well. Or they are staying in that environment where they cannot keep it clean or something. So that is the, it depends on the individual as well how they are living their life, and that will also decide the mortality rate of that particular individual. The other is the age-related disease that we have. This is something majority of people after certain age, we have heard about it after 30 right now. 25 to 30 age people also having BP issues. Okay, so it is we have to see the age-related disease. Firstly is atherosclerosis, any ischemic heart disease, diabetes, any genetic things, hypertension, Alzheimer's, Parkinson. So any age when people are crossing 50 to 55, we can see Alzheimer disease, Parkinson disease very prominent. Okay, so these are the four factors you have to, it's basic four factors you have to note down: intrinsic, environment, any lifestyle they are living, and the age related thing. Now they have given some theories to aging as well. They have observed some chromosomal changes happening. So they have given some examples. These are the changes has been seen, and they can note down if this changes happen, and these are the changes that happen and leads us to aging. That this is the reason why we are not able to respond well to any pathogen or any requirements, like hemostasis. As the mechanism of hemostasis is getting lower, why it's getting lower. So there's some particular theories has been given. The first is experimental cellular synthesis. So now everyone is able to see this image, right? This is just imagine this is a chromosome. Okay, at the edge of the chromosome we have telomere. Okay, now this is some enzyme which is very much important for cell to have the capability to replicate first of all, and second, to have to maintain their individuality. First thing is, just imagine it's a cardiac cell, or it's a skeleton muscle or anything. Now after some age, what will happen, this telomere gets lower down as much as cell replications are happening. Just imagine this first cell is at the age of 15, but we are seeing after 20 years or something, or after 15 years, means at the age of 35, the telomere, after the so many replication, this is getting lower down. And then again, at the age of 50 to 55, the amount of telomere is progressively shortened. Okay, so that results in too many things that interfere in the viability of the cell. This give the presence of aging, as the cell are not able to hold their individual. They cannot function the way they used to function, because what is happening, this enzyme, this particular enzyme is getting shortened. Okay, so I'll just read it out. If you cannot understand, then just let me know, because this is the basic thing. This is the only thing you have to remember in this experimental cellular one. So by vitro studies, many studies has been done in tissue culture. Okay, it has been observed that cultured human fibroblasts replicate for up to 50 population doubling, and then the culture dies out. It means that in vitro there is a reduced functional capacity to proliferate with age. So they have done a study in which what they have done, they have taken a fibroblast from a human body, they have taken a tissue culture, and then they have taken a fibroblast, and they have seen that it can just replicate till 50 some amount, and then it was not able to replicate because they lose their capacity to do that. So the some other study has also shown that the loss of chromosome 1, deletion of long arm, and even there's a progressive shortening of telomere present at the tip of the chromosome. Okay, these are the changes they have seen, which in normal cell is repaired by the presence of RNA enzyme. Now telomerase However, due to aging, there is inadequate presence of telomerase enzyme. Therefore, loss of telomere is not repaired, resulting in interference of the viability of the cell. So the how the cell should be, or it was the healthy cell, it is not like that. So the function of the cell at the basic, very basic level, at the chromosome level, it has been affected. These are the changes happening in age. Okay. So other thing is genetic control in intervertebrates. So now everyone know we have vertebrates. In between the vertebra, we have one gene called CLK, clock. Okay, it is very much important in controlling the rate and the time of aging. It has been said that that plays an important role, or that decides at what rate one person is going to age and at what time. Okay, so clock gene responsible for controlling the rate and time of aging have been identified in lower intervertebra. Example, CLK1, that is known as gene mutation into metazoa, results in prolonging lifespan. So they have just given an example. Okay, when there was a mutation of this gene happening in a worm, the life expectancy or the lifespan of that worm was increased. Okay, so these are the changes that is happening. The other is disease of accelerated aging. Now there are some heritage conditions also we are having, like baldness, characters, coronary artery disease, any Warner syndrome, any atherosclerosis disease. As I told you, okay, we have certain disease which are inherited. Okay, certain kind of cell has been structured in certain way in our body that they will function in that way, and that will lead us to have some artery thickening or some mutation happening at certain level that will end up having certain kind of disease in our life. Okay, so in a heritable condition associated with the signing of accelerated aging process, progression seen in the children is characterized by the baldness, cataracts, coronary artery disease. Another example is the Werner syndrome, a rare autosomal recessive disease characterized by the similar feature of premature aging, atherosclerosis, risk of developing various cancer. So these are the things can happen if our parents are also having, or the generation, or due to their lifestyle they have developed, and now it has been given to generation back. Okay. The other is oxidative stress hypothesis. In this, what happened, as we have discussed earlier, that there are some oxygen radicals we have that do not get absorbed, but they are very toxic. So when we have that high level of oxidative stress, means when we have that high level of toxin, oxygen of toxin, this leads to aging, and that leads to cell death. In a functional way, they will be very reduced. So aging is partially caused by progressive and reversible molecular oxidative damage due to persistent oxidative stress. When we are having persistent oxidative stress, what happened? Aging partially caused this. First thing is, in normal cell, very small amount of 3% of total oxygen consumption by the cell is converted into reactive oxygen species. The rate of generation of reactive oxygen species is directly correlated with the metabolic rate of organism. With age, what are they saying? Okay, just imagine 100% of oxygen they are taking. They're just giving an example. Okay, out of that, only 3% of oxygen is getting converted. That can one person can be used, can use it. Now, how this conversion is happening? It depends on the metabolic rate, how fast your ATP is getting generated, how fast your mitochondria is generating ATP, how fast the cycle is taking place in your body, how fast your enzymes are reacting. That is metabolic rate. Okay, now this metabolic rate depends and decides that how much oxygen that species is going to have. Okay, so with age, what happened? We have lower metabolic rate. So there is a low metabolic rate with generation of toxic or oxygen radicals, which fails to get eliminated, causing their accumulation, hence cell damage due to mitochondrial injuries. role of antioxidant in retarding the oxidant damage has been reported to some studies. So this is things will be happen if there is low metabolic rate. So we won't be able to remove that toxin, and ultimately what will happen, those oxygen radicals which we have seen in very early part of this lecture, that this toxic oxygen leads to cell death while damaging the mitochondria. So in aging, this also plays a very important role. The fourth is hormonal decline. As everyone knows, okay, after certain age, the production of testosterone or estrogen is very low. That's why the female are having menopause, and even lower testosterone is seen. Lower level of testosterone are seen in male. So with age, there is a loss of secretion of some hormones that will reduce the functional decline. Now, defective host defense. Sometimes what happens, the ability. Now, basically, this is very common. Everyone would know that aging is caused when we are not, a person is not able to respond well. Okay, if I'm getting fever at this age, at the age of 24, 25, or someone is having at the age of 55 or 56, the response for them would be very different. They might be having other things as well reactively. Their body won't react that much. They will need certain kind of medication. Some side effects would be seen. So there are many things that are affecting. So the host defense is very different with aging. Okay, it gets reduced and they cannot do it in a better way. Even when you're having cell are lost, they cannot renew. The rate of renewal is also less, so that can be also one reason that one is having aging or why the aging is happening. Okay, so these seven things are clear to you all. The theories. Any doubt in any theory?
No, ma'am.
Okay, the first two I think so that was new. Other than that, it was simple. Okay. Now, what are the organ changes we are seeing? There's a basic, we'll just go through previous neurological or musculoskeletons. What are the changes? What are the deterioration we are observing at muscle level? Any elasticity has been reduced. You know, the old age people do not have that elasticity in their muscles. Their muscles are very soft and they don't have the tone. Okay, so these are the basic changes that happen in aging. So we'll just go through that. The first is cardiovascular system. In that, atherosclerosis with calcification, monarch bush medical calcification, brown atrophy of the heart, loss of elastic tissue from aorta, major arterial trunks. So atherosclerosis, why they keep on saying that? Because the heart is not going to pump at the same manner. uh, it will get tired or it will need some help when, if their lifestyle is so difficult or they have very different lifestyle that is getting accumulated in the arteries or something plaque formation is happening. So when it comes to cardiovascular, this is the simplest and the one thing that keeps happening is atherosclerosis. There's a plaque formation in the arteries, so that leads to, heart has to pump more. Just imagine heart has to pump really too much, and that will give to hypertrophy of the heart. EV nodes won't be working that much. Ventricular hypertrophy will happen. So these are the other things that happen. Fibrillation will happen, but it starts with atherosclerosis where the heart has to pump more. This is the reason. Okay, so this is the basic that happens, and then it leads to uh, you know hypertrophy of the heart, AV node, those other things. In nervous system, atrophy of the gyrus sulci, Alzheimer's disease, Parkinson disease, you can see when the dopamine are not being released or not being made itself in Parkinson disease. If you know, the dopamine production is nil. So we have to keep giving them. It's a lifelong disease, I think so. In the musculoskeleton, what happens? Degenerative bone disease. Everyone know cartilage get damaged, OA, and arthritic changes that happen, loss of bone density. They get very brittle. Osteopenia is majorly seen in patient as well. There was this patient I've seen recently. She was having Parkinson since 10 years. Okay, so after that she had some sepsis and she was paralyzed. Okay, for that reason, she had a cock spine. That is the TB of thoracic spine, which is basically seen in the sepsis seen in the T10 to T12 level. Okay, so what happened? She took some physio, and with a normal movement of abduction, she got her humerus bone broke. Okay, the humerus bone just got broken. So then she got a thing that it was a osteopenia. So with age, these are the many things affecting. So first she had Parkinson, then she had DVT, she got operated, and then the sepsis traveled to the spine, and then that's how she got it. And so these are the many things happening in old age. That's how our body responds. In young age, you won't be expecting this many complications. Okay. Age-related muscular degeneration, the tone of the muscle is reduced, the elasticity of the muscle is reduced. In eyes, what you see, the due to there's a vision deterioration, the vision optic nerve is not working that much, or there is the layer of the corona is not working, or vascular changes happening in retina. Hearing, disability of hearing, senility related to osteosclerosis. Even when the ears are getting affected, as vestibular system is there, so their balance is also affected. As we see in aging, they do not have a balance. They have major balance issue in their life. Immune system, there's a reduced IgG response to antigen, frequent and more severe infection. They are very much prone to get infection in their life. Other is skin laxity, or as I said, loss of elasticity in the tissue, and cancer, well, for many reasons. So this is the aging. If it's write a note on aging has been asked, so you just have to include this few things, the factors that are affecting the aging and the theories. Okay, you don't have to write the organ changes in the aging, but these two things is not that important, but it's good that if you know, okay, what are the changes you can expect at what age. Okay, so it's a simple topic. I hope everyone understood it. Any doubts regarding this? Anything?
No, ma'am, clear.
Clear? Okay. So pathology, we have completed one chapter. So next I'm going to start the pharmacology. So I'll just share the slides which I'm going to make you study through that. I have few slides for pharmac. So we'll go through that. Okay. So by tomorrow morning, you'll have that slide with you. I'll just share with Shahid and he'll just forward you all. Okay. So tomorrow we'll take pharmac whenever the next lecture we have. So this chapter is clear to you all, right? If you'll go through, to you'll understand what are the things to expect, gangrene and the cell death at cellular level. What are the things happening? Because this is very basic, and then we are going to take the healing part. I'll take the healing thing, the inflammation and everything. Okay.
Okay, ma'am.
Okay. So next lecture will start with pharmac. Okay.